Hey, what's up, you guys? Page 262. We're going to go ahead and tackle the getting started from lesson 5 of our topic. You should have your geometry tools, compass, protractor, etc. Let's start off by using the compass to construct a circle and label the center. Well, I'm going to start by actually label the center first, and then put the compass center on that space and draw a circle. It doesn't have to be a certain size. Your circle might be a little bit smaller, a little bit different, bigger than mine, but just make one. Now, it continues on. Then draw any 3 points on the circle. So let's draw 3 points and label them A, B, C. And then last, we'll take the protractor and we'll use the protractor to connect those points and create chords. Remember, a chord is a section of the circle that crosses from one side of the circle, if there's a side, or one edge of the circle to the other, and maybe it goes through the middle, but it definitely, when you connect those 3 points, we've created a triangle. You've created a triangle with 3 sides, 3 points. There it is. We're going to use this image to build on the idea today of something called a circumcenter, where the triangle itself is completely contained on the edge of a circle. What is the relationship between the center of the circle and each vertex of your triangle? Well, let's draw them in. Let's draw OB, maybe even draw a little longer line, just because we want to acknowledge that if you connect OB and draw through, you get a diameter, right? You get this line that goes from one edge through the center to the other. OB and OA should have a spike on them because they are created as radius, a radius or radii of the circle. So from O to A, O to B, O to C, the center of the circle out, those are all radiuses, radii of the circle. And so therefore, if they're radii of the circle, they must be the same length. Let's highlight them all the same color. Okay. OA is the segment, is congruent to OB, and is congruent to OC, because they are radii. Let's get ready with the next one. We're going to compare your triangle to a classmate's, or maybe compare the triangle that you created on your paper to the one that I created. What similarities do you notice? Essentially, we have the same relationship, that your center to the vertex of each vertex is going to be the same. You will have a different shape for your triangle, but it's all based upon how we constructed the points on the edge of the circle, so they have the same radius from each point. Number 4, in the next one, we're going to draw 3 lines, which I guess is already done if you see how I drew my radius and then extended it to the other side. We're going to draw 3 lines which pass through the center of the circle and through a vertex of your triangle. So we're done. We did that. Now, these lines that we drew are concurrent. Concurrent means, it's a vocab word, so highlight it. Concurrent means that they meet at one point. In fact, we're going to call that point the point of concurrency. It's where lines, rays, its segments, etc. all intersect. And if all 3 of them come together, in this case, they come together at point O, that tells us that we have a special relationship for the center of our triangle. This is, in one case, a center of the triangle. Are there other sets of 3 lines that pass through the circle? Well, yes. Through the center of a circle, there are infinitely many. But because of our 3 points that we created, then those 3 points are really specifically related to the triangle. But are there other 3 lines that pass through the center of a triangle? Yeah, there are infinitely many number of lines that pass through the center of the triangle. These are all diameters. The points of concurrency happen when diameters of a circle intersect. And we're going to call this a center of the circle that we're close to. Thanks for watching this video. We'll see you in the next one.